Okay, so you have chosen a very interesting curve here. Maybe I can do a better job of getting this on screen. Oops. Or maybe I could do a worse job. All right, so you have chosen the x value to be cosine of t squared.
Yep.
And the y value to be cosine of 3t over 2. So we get something that's really wiggling back and forth all over the place. All right, so what do you think the velocity vector is doing here?
Well, it's sort of like it's being pulled this way and then really hard back this way and then hard. But there's this part where it's just being pulled slightly and then it just pull this way, pull this way.
Okay. My guess is in order to graph this one, I'm going to have to shrink the velocity vector back down. So I'm going to go to 0.2 again.
All right.
Because it looks like this thing's really moving quickly. And I'll shrink the acceleration vector back down, 0.2, 0.2. Okay. So what do you think is happening with the velocity vector here?
So it looks like for most of the time, the velocity is going to be super strong, maybe like almost horizontally pulled in one direction or another.
Okay.
It's going to be going pretty fast.
So there's the velocity vector at the beginning.
It's horizontal.
And so
And it comes back down even quicker.
the velocity vector really isn't about which way it's being pulled, it's about which way it's going.
But it's going pretty fast for most of it.
Yeah, it sure is. Because
It actually speeds up. Like,
oh yeah, why do you think it speeds up?
Maybe
I guess
the turns are sharper.
Okay, yeah, why? Why do those turns get sharper?
It's just
Do you remember what the function is here?
I think it was like
cosine
3. You say cosine t squared?
Yeah, cosine of the quantity t squared.
So that's gonna have your cosine wave, but that's gonna get the space between the waves is gonna get less and less as t gets big.
Yeah, so it starts moving. Now the really interesting thing here is going to be, where do you think the acceleration vector is for this crazy thing?
It's gonna kind of follow the velocity vector. It's just gonna get pulled sharp, like both directions. Just gonna go back and forth.
All right, what do you think for the velocity vector?
I think that as well. Although, like right at the corners, right at the corners might be the turning points might be the sharpest, steepest.
All right.
Oof.
So it looks like it's kind of going a little bit opposite, and it's mostly horizontal.
Yeah, it certainly looks like it's almost always horizontal. It's the thing's moving so fast back and forth. So it's slowing down. Now it's pointing left, right, left, right, left, right. So trying to pull this thing back and forth all the time.
Yeah.
And the velocity vector, even dividing by 5, the acceleration vector is off the screen.
Yep.
All right. So one last one. This time I'm gonna pick.
Okay.
And I'll show you something neat. All right.
All right.